Hi everyone. This is the demo for the Sustainable LLM API V2, which is our LCA tool. This is the next generation AI system that combines neural ODEs, knowledge graphs, and optimal control, Bayesian inference, and NASA's Earth Observatory data integration to help organizations make sustainable decisions. We deployed this API as a fast API backend on Vercel. So today I'll walk you through the different endpoints and show some sample requests and explain the outputs. So as you can see, the root endpoints gives us a simple welcome page, as in we get a complete dashboard sort of thing, confirming that the API is running. And then now we'll be exploring the different features. Just a second. So here we can see how many active projects are there and what is the current carbon footprint of your location, the circularity score, and then the cost savings in dollars, because as of now that is the global currency. And then here we can always start off with a new scenario, and we can click on aluminum or the current four metals which we are supporting right now, and we'll of course improve the options and then increase the number of options as we go. This is just for the prototype phase. So let us say copper, and then in the APAC region, Asia Pacific region, and then we're going to generate a scenario as in what this is going to do. So here, the material is copper, and then the region is APAC. The baseline year is 2020, and then the target year is 2035, as you can see here, 2020, and then 2035. Here you can see that we have factors such as carbon tax, renewables, and supply chain shock. The model generates a trajectory year by year with variables like carbon tax, energy mix, material availability, and then predicted emissions. And then we also get recommendations on how to handle these sustainability challenges. This works on a neural ODE, like we forecast realistic sustainability pathways under uncertainty. So here you can see predicted emissions and stuff. And then we get the driving factors, the carbon tax, energy mix, and availability, as I told you, in a graphical and a more visual format, which is not currently available in the existing solution, which is OpenLCA. And then we have AI recommendations too, implementing carbon tax at $10 per ton in 2025, increasing by $5 annually, etc. So we can use this, and statisticians can use this, investors can use this to make much more, what do you say, uh, calculated risks on investing their money. And then we have the AI chat. This is mainly for this is mainly powered by an LLM and a graph neural ODE. We project both of these embeddings into a latent space, joint latent space for natural language insights. This is for everyday people to make more out of LCA. Currently, only industry experts and professionals can use LCA tools. Now we have this natural language insight so that everyone can use it. As in, I can say, yeah, here is a common question. We can say, what's the carbon impact of recycled versus virgin aluminum? And if I enter, I'll get the output. Just a second. Huh. Here we can see it gives the complete calculated output. And then this is working on, by the way, DeepSeek, DeepSeek R1, which has been fine-tuned using QLoRa. We've quantized it, and then we have used basic parameter efficient fine-tuning. And here you can see the confidence ratio and then the sources too, the complete knowledge base. Currently, it is Earth Observatory data and some other material data sets which are completely openly available. We are open to provide them as you ask, if you ask. And then we can have follow-up questions like what are the environmental impact, etc. And then we of course do get answers for those two. And then we do get sources also. And then coming to the next feature, which is the forecast feature, AI enhanced impact forecasting feature. Here we can say we forecast Earth impacts using spatiotemporal climate signals. If we input supplier region, which is India, and then coordinates, let us say, let me just show you, make a run through. Okay, we'll go with the example here. Let's say copper mining, and then we'll put in these coordinates 19.75, or we can put something else too, like 20.75. Not much of a difference, right? 75.713, I guess. And then let us say the land use. Now we are processing Earth Observatory data freely and openly available through NASA's data. Like there is NASA EO data and then ISRO EO data too. We are combining these top two space agencies' openly available data to get to these projections. We can see here it is Maharashtra, India, and then we have a low water stress level, but then extreme drought risk is there in 2035, and there's an increasing risk. We can see a complete analysis too. We can have a projected drought index. This is the previous drought index. This is the current drought index in 2025, and these are the projected drought indices. So we have the precipitation forecast too, expected rainfall patterns and all. Currently, it is very stormy and stuff, but then the government is making considerably good changes so that you know there'll be much of less storms and global warming stuff. We have risk distribution too in a very, what do you say, visual way. You can see that year by year we have this, what do you say, segmented pie chart sort of thing where we classify the risk. And then we have the key environmental factors too for each year with the risk factors and then the percentages, drought risk and precipitation percentage. Finally, we come to the recommendations, as in what can we do to, mitigate all the climatic risks. These are the strategies which are provided by the AI itself. And then, yeah, this uses NASA, ESA, and ISRO. I forgot to mention ISRO here, but then we also use the ISRO Earth Observatory data with the real-time market share data. And then we have finally the advisory. Let me just promote parts, and then let us say this is primary aluminum, and we currently require durability, lightweight because it's automotive parts, and then thermal stability too. And then we'll get what do you say, complete alternative to primary aluminum, which we can use. Huh. So how this works is we like any real world data comes in with wait, just a second, yeah, any real world data. Okay, let's say we are designing a water bottle and we currently use virgin plastic. We pass in constraints like cost, recyclability, etc. Currently, we are designing an automotive part, so we passed thermal stability, strength, etc. We pass in constraints, and then the system returns a set of alternatives. Example: this magnesium alloy, and then expected GHG reduction, cost change, recyclability score, and the best choice among them, and a justification too, as in why this is correct. This endpoint treats sustainability like an optimal control problem and balancing multiple objectives and constraints. Coming up, we have uncertainty analysis. This is the something which is final. Let us say we have an impact score of 110.5, and then or 120 confidence level. Okay, let's use these placeholders for now. And then when we pass this, what we are going to do is any real world data that comes with uncertainty. That's what we show. If an input impact score of 110.5 kgs of CO2 with a 90% of confidence, then the system returns a confidence interval and then the percentage uncertainty, the major sources of uncertainty like supply chain variability or data quality, and an explanation in plain language, like what is it, natural language. This ensures decision makers understand the reliability of the results so that we won't be taking blind decisions. Here you can see uncertainty score, climate change, best estimate, a lower bound and upper bound. And then here is the explanation, the rationale which we took while making this choice. We do have the recommendations too. And then last but not the least, we have the benchmark. Let me show a demo of this smartphone. Okay, and then we select an industry, consumer electronics. Let's say 115. This is 215, 0.6. I'm running a benchmark score. Finally, we have this benchmarking. Suppose our product is a smartphone, like I've entered, and we input its impact factors, and the system compares it against industry averages and the best-in-class performances. The output includes a comparison narrative, like, and recommendations to move closer to the best-in-class sustainability. This is like a dynamic performance dashboard powered by AI. So this is the thing. You can see the water footprint. I mean, it gives a complete analysis, like an overview, as in what is our current situation and what do we need? We need improvement right now, and then some numbers and statistics so that we can take more informed decisions, and a graphical representation for let us say a business is using this tool. They want to uh, show it in a more visually appealing way, or maybe um, someone who doesn't have much knowledge in this subject is using the tool, and then they want it to be visually appealing so that they can understand it clearly. So we have this industry benchmark comparison. So we have the our product GHG score, and then the industry average, and then the best in class. Similarly for all the three, what do you say, metrics: recyclability and the water footprint. We have sustainability radar. You can see this, the same thing in a different, what do you say, view. And then the improvement plan is just the recommendations again. So uh, to summarize, the sustainability LLM API, which we created, uh, which is now a part of LCA intelligence, offers these following features. Like we have scenario forecasting, knowledge graph enhanced queries, climate impact forecast, material substitution advice, uncertainty analysis, benchmarking against industry. So all the endpoints are JSON schema enforced, and all the neural ODE models and the LLM models have been deployed on, what do you say, AWS, and then the API is powered through Vercel, ensuring structured and reliable outputs that can be easily integrated into any front end or a decision support system. So thank you for watching this demo. We do have mathematical backing of our, what do you say, AI models too. If you guys want to have, what do you say, a more scientific backing to our solution, we are open to provide this. Thank you.